In this video, we will derive the voltage across capacitor in source-free RC circuit. Here is the RC circuit. It has no source, but the condition is at t equals to 0 when there is no source in a circuit, it is called as source-free circuit. So consider this as a node and the two outgoing currents from these nodes are IC through capacitor and IR through resistor. Initially, at t equals to 0, the voltage across capacitor is V0. That means capacitor is charged at t equals to 0. To find the equation for voltage across capacitor, first apply KCL. So KCL, IC plus IR equals to 0. The current through capacitor is given by C dVc by dt, and the current through resistor follows the Ohm's law, so Vc by R equals to 0. Divide whole equation by C, we will get dVc by dt plus Vc upon Rc. Further, we will separate the variables Vc on left hand side and T on right hand side. Follow these steps. dVc by dt equals to minus Vc upon Rc. Then Vc we will take on the left hand side and dt on the right hand side. Let us integrate both the sides. Integrate both the sides, but left hand side we have to integrate with respect to Vc, and on the left hand side we will integrate with respect to T. So it will be log of Vc equals to minus 1 upon Rc, which is the constant, T plus K. K is the constant of integration. So let us first find the value of K. To find the value of K, put the condition at t equals to 0. Put Vc of 0 is equals to V0 at t equals to 0. So in this case, the equation 1 will become ln V0 equals to minus 1 by Rc multiplied by 0 because time is 0 plus K. Hence, K is equals to ln V0. So this will be the K. Substitute this K in equation 1. So equation 1 will become ln Vc equals to minus 1 upon Rc T plus ln V0. Now shift both the logarithmic terms on the left hand side and apply the logarithmic algebra. So here we can write ln Vc upon V0 equals to minus 1 upon Rct. To find the value of Vc, we can take the antilog of this equation. Right? So by taking antilog on both the sides, right, we will get Vc upon V0 equals to e to the power minus 1 upon Rct. Or we can say that Vc is equals to capital V0 e to the power 1 upon Rc into t for t greater than 0. So this is the equation for the voltage across capacitor in a source free circuit. Further, we will see what is RC. RC is nothing but a tau. It is called as time constant. The definition of time constant is the time taken by capacitor to discharge or charge 63.2% of its steady state value. Okay, so remember this definition. Okay, now if we will replace it, e to the power t by tau we can write. So in terms of tau, this is the equation of voltage across capacitor in a source free circuit. Okay, this is the in terms of tau. Now if we will find the different values of tau, like at t equals to tau, what is the value of Vc? At t equals to 2 tau, at t equals to, let it be 5 tau. Okay, so you can also find at 3 tau, 4 tau, but if you will find these values, then you will see that at t equals to tau, Vc will become V0 e to the power minus tau by tau, that is V0 e to the power minus 1. The value of e to the power minus 1 is 0.367 and it will become 0.367 times V0. If we will see at t equals to 2 tau, the value of Vc is e to the power minus 2 and the value of e to the power minus 2 is 0.135. Similarly, when we will find the value of Vc at t equals to 5 times tau, then it will be V0 e to the power minus 5 and the value will become very small, which is approximately near to the 0. So we can conclude that at t equals to 5 times tau, that is the time constant, right, the capacitor discharges fully. Now we can plot the response of this circuit, right? So it is the x-axis time, y-axis Vc, it is the origin. So at t equals to 0, from this equation you can see that at t equals to 0 Vc becomes V0. So at time t equals to 0 the voltage across capacitor is V0 that we have already defined at the starting. Now as the equation says, the voltage across capacitor exponentially decreases. The behavior is exponential and it is decreasing. So it will decrease exponentially. And what will happen at t equals to infinity? If we will substitute t equals to infinity in this equation, it will become e to the power minus infinity and the value of e to the power minus infinity is 0. So Vc, voltage across capacitor, become 0. Right? So we can say here that it is tau, then 2 tau, further 3 tau, 4 tau, and at 5 tau it is nearly 0, reaching to its steady state value. That is, in this case, source free RC circuit, it will fully discharge, that is 0. This is the response of source free RC circuit.